So yeah, welcome. As Julia said, I'm the owner operator of Cameo Magic. I started as just being a YouTube channel, primarily working on SysML and Cameo systems modeler as my tool. And we've kind of grown, and now I do consulting for the same thing, kind of expanded. And so recently I went to a symposium out in Reno, Nevada, and they talked a lot about how AI is impacting MBSE. And so I've kind of pulled a lot of the talks which I heard and I talked to some of these people about and put them into this slide deck here. So today's talk is a tour of how AI is actually changing MBSE work right now. It's not the hype, it's like real terms. So like real companies like Ford and Dassault. Dassault is the creator of the Cameo Systems Modeler tool. And we'll give you a map of the six concrete impact areas, the tools behind them, some of the risks, and then how you can start applying this like next week. So we'll hold our questions to the end, and we're going to have time, so I'll keep going. So quick context on me. I publish videos on YouTube, and then I do a lot of consulting gigs. I have a background in DoD, so most of my stuff is DoD related. And yeah, we'll post the case studies in the bottom of each of these slides so that you can see what sources I'm coming from. So here's the agenda. So we have six impact areas ordered roughly from the most disruptive. So AI is literally generating your models for you out to kind of the less disruptive, the adjacent waves in CAD and simulation that you see in number six there. So after these six, we'll pull the common thread and we'll talk about the risks, and then we'll give you some concrete ways on how to start and then explain where this could go next. So before we get started with our six, we'll kind of name the disease. So across MBSE, we have some familiar pain points that you're seeing up here. So like work is trapped into documents. We have mountains of manual repetitive modeling. We have context scattered across a bunch of different tools. And then we have just a few number of experts that know how to do all this. So AI is meant to, impact one, if not all four of these pillars that you're seeing here. So the next thing is why now? Why do we care? Why is this happening in 2026 and not, let's say, 2019? So we got some enablers. So one, the LLMs are just extraordinarily good at pattern following. Then number two, we got SysML v2, which just came out. It finally gives us a textual notation. And so the model, basically you can get the AI to write you this textual notation, and then tools such as CATIA Magic can ingest that code and then create diagrams for you. And then number three, we've got with SysML v2, we've got open interfaces now, so we can use REST APIs and MCPs. And that is going to allow us to just interface with the tool so much better, faster, more efficiently. And then four, we're closing in our standards, which is really helpful. It's not quite as the Wild West as it was. We're getting a little bit better and, pushing towards standards, towards a connected, more traceable models is exactly what AI needs to create a good output. So now we'll get started with the 1 through 6. So this is the most disruptive one. So this is the one everybody wants to talk about. The dream of describing a system in plain language and then getting a real valid model out the other side. There's some important caveats to this, and we'll look at where we are right now. So here's our first example. You see on the bottom it says Doug with Caltech. So the single most important practical lesson is you don't just ask an LLM for a SysML v2 model and just hope for the best. And so you get a style guide, you curate some Cameo compliant code samples, and then like one per diagram type, and then the AI follows these as a syntax reference. And you basically just do it little bits at a time. And Doug and his team have basically created this template in order to increase their right first time pass rate at above 90%. So they're pretty confident that the AI is not hallucinating and giving you just trash data. And so he's basically taken this and allowed it to create a Cameo compliant model, which is not the same thing as a SysML v2 compliant model. So each of the tool vendors are going to have their own specific dialect of SysML v2. They're going to implement it slightly differently. And so essentially, you're going to have to work and play with your AI to make sure that it is able to be tool compliant, not just the language SysML v2 compliant. So he's done this, and it is a pretty cool demo. He actually did a lunar lander demo. So step one was showing his templates and how you go from, natural language to creating a SysML v2 model. And then what you're seeing right here is step two, which would be you have your SysML v2 model, and then you're trying to output different specs. So the lunar lander model makes this concrete. It one prompt yields a complete high-level spec that cleanly maps to the classic SysML diagram types. And then they do like one prompt per subsystem, which fills in the logical architecture. And so he built a Claude app, which basically allows you to flip the value proposition. The model isn't just documentation, it becomes the precise specification that drives the agentic code generation downstream. So pretty cool stuff, and it seems to be reasonably scalable. But you just have to, take what is being presented to you with a grain of salt. So the lunar lander model demo was just a demo and not a full-scale production project. So we just have to understand that. The next one is Ford. We all know Ford, the motor company. They are coming at this from a completely opposite side of the spectrum. So we just talked about kind of like the greenfield, like we're just designing aspect. Ford obviously has all of their stuff, archived for the past 40 years, if not more than that, on random napkins that they've got, in filing cabinets. And so they're focused on sustainability and stuff like that. So the RAML, which is reliability, availability, maintainability, manufacturability, and logistics. And so AI image recognition has helped them convert legacy data into model-based data, and you can see the steps that they've taken there. So basically, Ford shows how they take the old pictures and then they're able to take those sketches, boundary diagrams, and use AI to extract them, create elements, and map them to curated reuse libraries so terminology is standardized. It seems also this one seems more practical and like they're already getting a return on investment. And so I thought this was a pretty cool talk. So the next is not the AI is going to do everything for you. It's more AI is a force multiplier. So if you're nervous about your job, this is going to make you feel a little bit better. This is kind of the counterweight to that. So across, uh, basically, AI is not an autopilot, and you have to be very careful about that because if you feed it things that are wrong, then it's just going to multiply that wrongness. So the teams that succeed, this is kind of another pattern. The teams that succeed are deliberate in how they hand the AI information and how they get a human in the loop to make sure that the output from the AI is correct. So next we'll look at Chris Armstrong's. Chris is a little bit more skeptical. He thinks that the modelers should be continuing to model. The AI shouldn't be doing the modeling. And basically, he's saying that the AI should be used to free up time for the modeler to do more modeling. So it's AI is good at the mundane stuff that modelers hate, like keeping models current, correlating content, enforcing standards, formatting for different audiences, etc. And he's saying that the AI should just, automate that stuff and let the modeler do more modeling, which is a little bit different than the previous approaches. So I guess what you're going to see here is a lot of different opinions, and that's just kind of to show that like not everybody has exactly the same vision. And I think that the end-all solution is kind of a mixture of all the different visions that you're seeing in this talk. Next, we have let's see. This is the kind of the quiet thesis of this whole talk. Every team that got AI working did the same thing at first. They standardized. So you need to standardize before you implement AI. The style guide, a reuse library, an authoritative model, some sort of standard to begin with. And the reason it's simple, as I said before, whatever you give it, it's going to multiply it. So you point it at chaos, you're going to get faster chaos. You point it at curated standard, you're going to get a trustworthy like result. And every one of them kept a human as the verification gate. If you remember just one thing, invest in the standards and reuse libraries before you invest in AI. So now is the place AI is delivering hard. This is the DFMEA, which is design failure mode and effects analysis. So this is just a really good or a case study that they had, and essentially Dassault and Capgemini went and they put a number on it. They said 60 to 80% reduction in manual DFMEA effort. So basically, in the past, you would have to use a bunch of spreadsheets, and it was very hard to recognize the pattern. And all of these projects were independent and siloed. So each project would get a whole different spreadsheet, and it was much more difficult to understand the failure mode pattern. And the AI was able to basically take all of the different product lines from this company and identify and all the spreadsheets that they had used in the past, and then identify the patterns and really see a return on investment. So this is kind of like your good example of how it has already helped and worked. Number 4. So this one's going to help or excite the software engineers because it's basically talking about your world. So the idea is to stop treating models as documents and start treating them like code. So we'll version them, we'll validate them, and continuously and let agents operate the tools through open interfaces. So Salius makes the case that the gap between fast software and slower systems engineering closes when you treat models like code. This resonates with me very well, and I like Salius a lot. I respect the stuff that he comes out with. He's on the cutting edge, and this was a really cool demo. So we're going to store the model in a repo, and on every push, automatically run validation rules, simulations, trade studies, requirement verification, and you're going to fail early and often. So you don't have this problem where you wait, and then you finally integrate, and then you have this cluster at the end trying to integrate it all. So he demos the real tool chain with actual softwares. So he uses Cameo V2 with Teamwork Cloud, triggering a GitLab CI/CD job, pushing parameterized requirements onto 3D CAD, syncing the requirements with Polarion. And so he's connecting this whole tool chain together to show it automate, and you can make a change and verify it immediately. It's very cool. So CI/CD is continuous integration, continuous deployment, or continuous delivery, if you didn't know. So next is MCP and agents. So MCP is the Model Context Protocol. It's a standard developed by Anthropic that lets Claude connect to external tools. And so it's another piece that software engineers should be focused on. It's the standard that lets the AI agent actually read and drive engineering tools in natural language. So Dassault showed this using their 3D experience, which is their software, their MCP server exposing about 100 tools. It's an emerging pattern is essentially two steps, the MCP to identify and expose the workflow, and then use the CI/CD to automate it. So in this, they Evercurrent has their own AI agent that they call Eve. Their AI agent, basically, what their pitch is saying is that it's going to help you with decision making, and so it's able to, uh, I guess, speed up the cross-functional decision making effort so that you don't have this bottleneck effect. Fair warning, this is a pretty big pitch. So, I would say that, we have to be cautious of how much we want the AI to be doing our decision making. So number five, it's about legacy documents. AI is increasing the bridge from that pile of ICD and specs to an authoritative, traceable digital thread. We kind of already touched on this at the very beginning where we talked about Ford converting their stuff using AI recognition. This one is, let's see, by Quest Defense. So they've got an adaptive engineering, and essentially it's a toolbox of MBSE plus automation plus AI. So it's not a single product. Um, I'm noticing that a lot of companies have their own AI agent that they're trying to sell to everybody else. So that is another theme. So anyway, they anchor everything in one authoritative model in Cameo. So Cameo becomes the hub, and then they extend Cameo with plugins, macros, and API calls to external Python to ingest inconsistent ICDs and auto create elements. So yeah, so AI is the force multiplier for the nasty jobs. You're starting to hear some of the same verbiage, and that's intentional. So number six, this is the last one. So finally, what's going on adjacent to MBSE? So this isn't pure MBSE, but some of the tool chains and what they're doing and how the tool chains will be connecting to MBSE. And so we're going to kind of look at like a rapid fire of all of the different tool chains and kind of what they're doing. So we've got the AI surrogate models. So they got neural ODEs, which is ordinary differential equations, which are basically able to speed up the slow physics simulations. We have AI is pairing with engineers as a Modelica coding partner. That's another one. So we got generative CAD. I think that one's super cool. Is creating assemblies and production grade parts in CATIA. And we got ontology plus AI, which is automatically classifying model security levels. And we got explainable AI or XAI, which is being used for cost estimation. So that's going to be the XAI is explaining why a model made a prediction or decision rather than just treating it as a black box. So the point here is your model is increasingly sits in an ecosystem driven and AI driven. So now we're going to kind of connect some of the patterns that we just talked about between our 6 steps. So AI's center of gravity in MBSE is generation and extraction, making models from prompts, sketches, and old documents. That generation gets wrapped in a CI/CD and MCP pipelines, so it is continuous and not one-off. It's built on standards, style guides, and reuse libraries, and it is verified by humans. So that is kind of my talk in one gigantic sentence. So now we'll talk about the risks and yeah, we'll start with number 1. So hallucination is real. So remember, Cameo compliant is not the same as SysML v2 compliant. You can't just like feed it in a sentence and expect it to everything to work out appropriately. You gotta really work with it to weed out the bad. And number 2, skill atrophy is it's a subtle one. So if your junior engineers never learn to model, they can't judge the AI output. And if they can't judge the AI output, then essentially you're leaving a lot more room for error. And what did I say AI does to error just as well as the good? It multiplies it. So you need that. You don't just have to have, you can't just have a monkey in the loop. You have to have somebody that knows what they're talking about to weed out the bad. We got number 3. So AI amplifies bad standards as well. So we need to fix the standards. We need to close the gaps. We need to make it less gray area. And we're working very hard as a, I guess, whole group to do that. Number 4, we have models are sensitive IP. So we need to think about what we send the AI and what needs to be on the cloud versus on-prem and different classification levels. That is definitely something, I mean, anytime you were talking to Claude or ChatGPT, they can save that. So it's sometimes a big deal, especially with DoD stuff. 5, let's see, we got a lot of what you see at conferences is framing. So you have to kind of strip out the what is the talk and who is actually walking the walk. You got a lot of people with ideas, and you've got some of those people that are actually following through. So you kind of have to separate the pattern from the pitch. So that's kind of what I'm trying to get at. And I mean, there was over 140 presentations at this event, and the amount of times that I heard the word AI, and you've probably heard it in this speech, is just a lot. Everybody's talking about it. It's definitely the hype. I think that there are a lot of useful cases for this, but there are some risky things. You you give it a little bit too much of leeway, it will mess up. And then you won't realize it until you've messed something else up. Okay, and number 6, we have keep configuration management discipline. Don't just like pump whatever the AI gives you into the trunk and call it good. So it's kind of more of the same. So now we'll shift to like a practical app adoption roadmap. So how could I start this next week? So I've kind of made like 5 steps here. So step one is pick one painful, repetitive task, not your whole process, and then standardize that one painful, repetitive task, and then build a style guide and maybe a small reuse library. And so you're standardizing. And then number three, you're going to pilot a prompt to structured output to import flow with a human verification gate. And number four is once number three works, wrap it in a CI/CD pipeline and expose your tools via MCP so it becomes continuous and agent accessible. And then finally, number five, scale. So you can before you scale to other repetitive tasks, you should try and make sure that like first time the what is it called? The measure right the first time rate, for example, is pretty good. Make sure that your output is good before you start scaling to other tasks. But that would be how I would do it. So then you're kind of taking that crawl, walk, run approach that the government loves to use. So here are the key takeaways in 6 lines. So generation and extraction are the center of gravity. Standardize first. Treat models like code. DFMEA is right now what I'm seeing is the highest ROI. And then keep a human in the loop and then start small. So this is the where it goes next slide. So where's the puck going? So everybody's still using SysML v1 right now, and you haven't heard me talk about SysML v1 at all in this talk. Um, and that's because I've just been talking about where it's going, where it's going, where it's going. So I am a believer that SysML v2 is going to be widely adopted. It's going to become the foundation layer or the base layer that AI works on, just because it has that textual syntax, has the API, and it really covers a lot of gaps that V1 missed. That being said, when is that going to happen is a question that I don't know the answer to. The reality is that the software tools, the tool vendors have not caught up to what is needed to actually implement SysML v2 at scale. So that's just where we are. We can't make all the elements in SysML v2 in I don't think any tool that is out there right now. So we just have to like level set that. So I can say, yeah, SysML v2 is going to be the way to go, but I never really prefaced with everybody's still using SysML v1, and they are like fundamentally different. They have different meta models, they have different base models. And so it's not like this tiny little, upgrade to SysML v2 from v1. It's like an overhaul. So that being said, I think SysML v2 is going to be the way to go. We're going to move from single helpful prompts to multi-agent workflows across the lifecycle. And MCP, the model context protocol, spreads until operating a model's tool by natural language becomes normal. So you won't be putting blocks on a screen anymore. You're just going to be typing out what you want and then identifying what's wrong with whatever the output is. It will likely be a diagram that the tool shows you. And then you'll just type in, this is wrong, fix this, and it will do that for you. So it's going to be less, clicking around in the tool, more typing or talking to it. And then you've got continuous validation and explainability becomes the trust layer. So I think that this CI/CD thing is, and treating it like code is 100% the way to go. Solius is point on with what he was saying with his CI/CD pipeline. And then I think that that's it. So let me go to the next slide. Yeah, so recap, AI is reshaping MBSE through generation, extraction, and agentic pipelines, but standards and human verification are what make it real. We can go happy. I'm happy to go deeper in the Q&A, but that's really the end of it.